Okay, everyone. So we are going to do finding our confidence intervals on Google Docs. First, we're going to do it the long way, and then we'll do it with Excel Miner. So right now, we're doing it the long way. So the very first thing that you have to do is you have to find out what your regression is. Now, you can also run this in your calculator to run your regression, and that gives you out a little bit farther. But if you're only working on here, we're going to run the regression on here. So to do that, you have to actually build the scatter plot and find the trend line. So you're going to highlight your data and go Insert, Charts. And now it almost always is going to give you a line chart. I don't know why. And then just go over where it says line chart right here and click the scatter plot because that's what we want. So we're going to move this to a more convenient spot for ourselves. So right here. And to do that, to get the trend line, what you need to do is go over to Customize. And then you want to hit Series. And then you want to go down to Trend Line. So remember, trend line is just another word for the line of best fit. Okay. And notice it doesn't give me my my equation. So to get that, you need to go to Label. Right now it says none, and we're going to go down to Use Equation. Click on that, and now you see it pop up. You can hit Show R, Show R squared, but I really hate the way that they changed that. Used to be R squared was right below it, and now it's right next to it, so I think it looks really confusing. We're going to generate R squared anyway, so let's just get rid of it. Okay, so we need this, so I'm going to write, I guess I should have put a spot for our equation. I won't do that right now. Let's see. Let's do that. And we're going to say equation. And our equation is right here. Notice it doesn't have a y equals, so you're just going to say that y is equal to negative 2.33 x plus 88.8. Okay. All right. And from that, we're going to take the B1. B1, remember, little b1, that is the that is your test statistic. That is the slope of your line. So we're just going to take that negative 2.33, hit enter. And now we're going to come up and we're going to use this equation to get our predicted values because we need the predicted y. So these are the y hat sub i's. So we're going to create those. So the way you do that is you tell, hey, Sheets, I want you to work for me. So you're going to say equals, and then you're going to tell it what it equals. Well, it equals our equation, so negative 2.33 times, and we want it times our x value, so we're going to go over and click on the x value that we want it for, and then plus 88.8. And so this is here's our observed y, and here's our predicted y. Now, what I want to do is I want to not have to do that every single one, so I'm just going to say, hey, Google, I want you to do it for yourself. So I'm going to get my little crosshair over here, and I'm going to double click, and there it goes down. And now for my residuals, remember my residual is the observed minus the predicted. So I'm going to do that right here. So equals the observed, I'm just going to click on it, minus the predicted. Now I could have typed in the actual values, but if I do that, Google Sheets and Excel won't understand the what you're trying to do. They won't see that, oh, you're just taking the values from here. So it's not unless you cell reference that you, which is this, unless you cell reference that you can do that with it, which is what's really nice. So here are our residuals, and now we want our residuals squared because that's how we're going to get our SSE. Remember, the SSE is the sum of the residual squares. So we're going to say equals the residuals, and then to square it, we're going to go Shift 6 to get the little caret 2, and that says, hey, we're squaring it. Go enter, go back up, do our double click to, dang it. So if you do this, you got to be careful. So delete. We're going to hit up here and we're going to double click so it goes all the way down. If you have something in the column that you're trying to double click down, it will not do that. You have to actually highlight and drag it. So if you ever mess up and you mess up the whole thing, either hit undo or you have to actually physically click on it and drag it down. No. Okay. Did that change? Was it weird? No. Okay. It didn't change it. I had to check. Okay. So let's see. So the sum of the residual squares, that's what we're going to have next. So the SSE, that is the sum of these guys. So we're going to say equals the sum of, and now we have to go highlight them. If you are bad at highlighting, you can always type this in. You can find out what the first one is. That's E2, and then colon to the last one, E12, and so it knows that you're trying to sum between E2 and E12. Okay. And now the next thing we can do is we can find out the square root of the SSE and our degrees of freedom. So remember, our degrees of freedom are n minus 2. We could have put another one on here to find out our degrees of freedom. So if we didn't, if it was a lot and we wanted our degrees of freedom, oops, we could say equals count, and we're going to tell it, hey, we want you to count how many things are in here. Oops, count. I want you to count how many things I have here. But then it's degrees of freedom, so I need minus 2. And we can see that it's 9. But this is really small, so we don't need this. So what I can do is I can just count. I can see from 2 to 12. That's 11. 11 minus 2 is 9. So I know that my degrees of freedom are 9. So this is equal to the square, the SQ. Make sure that you don't put U because it will go away. So the square root of the SSE, so we're just going to click on the SSE, divided by our degrees of freedom, which in this case is 9. Enter, and there we go. So there's our S. So this is the S is that's the Y's oh my goodness. That is the standard deviation for our Y values. Okay, so, which is not what we're going to want. We're going to use the standard deviation of our Y values to get the standard deviation of our B1. So that's going to come up. All right, we need all of this just to do those couple of things, which is why we do the Excel minor, because doing it by hand is very long. Okay, so now we need to find Y bar. So remember, when you are like, oh, I don't remember which of my Y's I'm supposed to be taking the average of. Remember, I could have infinitely many predicted values because I could plug in infinitely many different X's. But I have finitely many observed Y's because I can't infinitely observe that many things. So I'm going to say equals the average of my observed Y's, and that's my Y bar. So that's the Y sample mean. Okay, there's my Y bar. So now I want to know the difference between my observed Y's and their average. So I'm going to say this is equal to my observed Y minus my Y bar. And now I'm going to hit enter. I need to go back up here and I need to adjust this because if I click down, what's going to happen, let's just do it really quick. I'm going to click down and notice it doesn't change the other values. In fact, here I have a weird value because I've got something weird going on over here. And what's happening is if you look, so it's C18 and then this goes down to C19. I didn't want that. I wanted C18 the whole way down. So I'm going to undo what I did. And what I need to do is I need to fix C18 in place. And this is what I was talking about. To fix it in place, you use the $sign. So I'm going to put the $sign around the C, so in front of the C and after the C. And when I do that, that tells Sheets and Excel, hey, I want that I want that cell to be fixed in place when I do my cell referencing. So now I can go up, get my little crosshairs, and I can double click, and now I can see that my C18 has stayed in place. Okay, now to get the so we're doing this to get the SSTO, which we need this to get our R squared. So to do this, we're going to take this and we're going to square it. So we're going to take each one of these, we're going to say equals this cell. Remember, it's shift 6 to get the caret squared. We're going to go up, click down, and now there's our differences in y's squared. So our SSTO is just the sum of these. So we're going to click on our SSTO. This is equal to the sum of, again, we're going to go highlight the column that we want to sum. Okay, here's our SSTO. So the R squared value, which we could have gotten over here, but now we're going to do it by hand, is the SSTO, so this guy, minus the SSE, this one, the sum of our residuals, squared, divided by the SSTO. So this is equal to, and I need to put parentheses around the top, so I do that subtraction first, the SSTO minus, that's my dog, mixtape, please be quiet, the SSE divided by the SSTO. And there we have our R squared. Mix, be quiet. I'm trying to make a video, baby. All right. And so here's our R squared. And to get our R, we need to do a little bit of, sorry, my dog. Hi, it's okay. I know. We need to do a little bit of being careful. So it is just the square root of R squared. I agree, but also it's about direction, right? And we notice our slope is negative, so our R needs to be negative. So when we do this, we need to be equal to the negative 1 times the square root SQRT, the square root of the one that we have above, and now we hit enter. And now we see that we've got the correct one. So we have our negative R matching up with the negative slope. So make sure that you're being careful when you take the square root of R to get your R. When you take the square root of R squared to get R, that you're making sure that you match up with the actual direction that the line is in. Okay, wow, that's a lot, right? We're almost done. We're about halfway there. All right, so now we're going to do the same thing that we did right here with our y's, but now we're going to do it for our x's because we need to find the standard error of B1. And to do that, we need the S, which we built already, and we need the difference in x's. So we need to find our x bar. So here we go for x bar. So we're going to, remember, that's just the average of the observed x's. So the average of our observed x's. Okay, and now we want the difference between the observed x and our x bar. So again, equals, here's our observed x minus our x bar. And this time before we hit enter, we remember, oh, I want to fix this in place. So I'm just going to go click up here. I'm going to click around the C, $, toggle over, $. So my $sign is around the letter, fixing that box in place. I'll hit enter, go up, and double click the lower right hand corner box to get it to come down. Now we want to square it, so equals this guy, shift 6 to get your caret squared, and hit enter, go up, and double click to have it come down. If you mess up with something like that, just hit the undo button. You can always go back. I have stuff like that happen to me all the time. So if you ever realize 3 clicks in, you've done something crazy, just go undo, 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 and take you back to where you were before. Okay, so this is the column that we want for our differences in x. So the SSTO is like the differences in Y, and the differences in X just don't have a name, which is really aggravating, right? Some things don't have a name. All right, so we're going to say equals the sum of, this is what we want the sum of, enter. All right, now we're done with all of our work up here, and all of our work is going to be down here from now. Okay, so the difference is in X, so now we want the standard error of B1. All of this by hand just to get the standard error of B1. I know, it's a lot. Click up a little bit so that we can see everything. Okay, the standard error of B1, as you look on your sheet, the formula is there, right? It is S, so the deviation in Y, divided by the square root of the differences in X. So I did not square root this. Be careful, I did not square root this, so I'm going to need to square root it down here when I take the standard error. So this is equal to S divided by the square root, SQ, square, be careful, make sure you hit the right one, the square root of the differences in X, and there we go. So this is the standard error of B1. Now, this is T star we're using, be careful, this is T star to build our confidence interval. So we could go look it up on SurfStat, that's fine, but we're not going to. Instead, we're going to have Google create it for us. So remember, you're going to use this formula, T inverse of alpha. Alpha is what's left over from our confidence interval. So if my confidence interval is 95%, then my alpha is 0.05%, and then comma the degrees of freedom. In this case, because we're using a linear equation, we have two independent variables, so it's n minus 2. So we're going to say equals T inverse of our alpha is 0.05. Make sure you're always doing it as a decimal, comma, our degrees of freedom we already talked about is 9. And then we're going to hit enter. So this is our critical value. Okay, so remember confidence intervals. Oops, I moved this over in a way where we can't see it. So I put a little reminder for you about how to build your confidence interval. Doesn't matter what confidence interval we're building. It's always our test statistic plus or minus the critical value times the standard error. When it's a means, it's X bar plus or minus whether we're in the T or the Z. That's going to depend right here. And then either the standard error or the standard deviation, depending on what we've created. And remember, the critical value times the standard error, this is called the margin of error. Okay, so here we go. We're going to build the lower one. So this is equal to, and to build the lower one, it's minus. So our test statistic, what are we building the interval around? It's around the slope. Remember, we're trying to figure out what is the actual slope of this line, because the slope of the line tells us how they're related. That's what we're curious about, not what my original or where I am when I have 0 for X. That's not that interesting. What's interesting is how are they related, and how are they related is our slope. So we're going to take our slope as our test statistic, and we're going to subtract our t-value times our standard error, which is the standard error of B1, right? That was the whole reason we're using B1, and we're using the standard error of B1, right? And there is our lower limit, and here's our upper limit. We're going to say equals, again, our test statistic, which is B1, and now we're doing the upper bound, so we're going to say plus our T star times our standard error, which is right here. We're going to hit enter. So it does look like they are definitely, so because we don't have 0 in here, they are negatively related. So that's good. So we're going to say something like, we are 95% confident that the true the true population or the true slope of the regression is between negative, I'm going to just round out 3 decimal places, negative 3.667 and negative 0.993. Make sure that you round up if you do that. Okay. Oops. And then to make this nice, we will go like that, and we'll tell it to wrap around. So it's in the, this makes it in the middle, and that makes it wrap around so that we can see it. All right, I'm going to build another one to talk about the hypothesis testing. So right now, here's the first part. Here is our confidence interval and what we would say about